very good morning to all my dear students. Children, I'm back with chemistry lab experiment 2. That is the second experiment, which is the third experiment in your manual, and we'll be talking about the metal reactivity series. In other words, we will be doing some displacement reactions and we'll find out the relative reactivity of different metals. In comparison with other metals, what is the chemical reactivity of a given metal? So in that way, we will be finding out the order, a descending or ascending order of the metal reactivity series of different metals here. Okay. So what will be our aim? It is nothing but observing the reactions of these metals, zinc, iron, aluminium and copper, on the following salt solutions. Like we have zinc sulfate, the salt solution of zinc, iron sulfate, copper sulfate and aluminium sulfate. So we'll see what is the action of these metals on all of these salt solutions, and then we'll be getting the relative, the comparison, comparison of the metal reactivity, the chemical reactivity of these metals, and we'll find out which one is more reactive than the other. Okay. So what is the principle behind this experiment? The principle behind this experiment is that the displacement reactions, how can you define a displacement reaction? Do you remember the definition of displacement reaction? It's nothing but it's a chemical reaction in which a more reactive metal displaces a lesser reactive metal or element from its compound, and it itself occupies the position of a lesser reactive element or metal and forms a new compound, and it displaces the less reactive element or metal. So what happens here? You can see that x plus, it can be represented in this manner, x plus yz gives rise to xz plus y. So x is the strong metal over here and y is a lesser reactive metal. This is a more reactive metal and y is a lesser reactive metal, which is in combination. It's nothing but yz is a salt solution, metal salt solution. Yz is a metal salt solution. Now, when these both are made to react with each other, you can see x takes the place of y. It occupies the place of y and forms, a metal salt with, now a different metal salt is formed with the metal, the stronger metal x, and y, which is nothing but, the lesser reactive element is displaced out. It's nothing but it's removed from its compound. So this is a displacement reaction, and it is entirely dependent on the metal reactivity series. So we already know about this metal reactivity series. Hydrogen is taken as a reference here. So all the elements above hydrogen and below hydrogen actually. You can see this is the most reactive metal, and as you go down, you will see the metal reactivity decreases. The chemical reactivity of metal decreases. So as you can see, potassium is the most reactive metal, and when it comes to nothing but gold, it is the least reactive metal. So based on the position, you can actually tell which one is more reactive. For example, if I say out of aluminium and iron, if you know the reactivity series, you can easily say that because iron is below aluminium in the metal reactivity series, this is lesser reactive when compared to aluminium. So what is this metal reactivity series? It's nothing but the arrangements of different metals in a vertical fashion, in a vertical column, based on the relative reactivity. The most reactive element is put on the top, and you can see that the least reactive element is kept at the bottom. So this is what we are going to do, and actual procedure what we are going to do is we will be taking 4 test tubes, and in each of them we will be putting these salt solution. We'll make salt solutions of zinc sulfate, iron sulfate, copper sulfate and aluminium sulfate, and we'll take all these salt solutions in 4 different test tubes, and we'll label them as all this: zinc sulfate, iron sulfate, copper sulfate and aluminium sulfate. Now to each like this, we will prepare some 4 sets. 4 salt solution test tubes. This is one set. Like this, we'll be preparing 4 more sets. And what we are going to do is we'll be putting metal, like in question. For example, if it is aluminium metal, we'll see how it reacts with all these things. So we'll put a small amount of aluminium metal. It can be aluminium foil, or it can be aluminium powder, which is easily available in our lab. So aluminium powder, that same pinch of aluminium powder, small amount of aluminium powder is put in all the 4 test tubes. We will put in zinc sulfate, we'll see the reaction, we'll observe the changes that will take place, and we'll record the observation, and then the same thing will repeat with iron sulfate, copper sulfate and aluminium sulfate, and we'll see where actually the reaction is happening. If the reaction happens, you need to understand one thing here. If the reaction happens, then we can say that aluminium, if it is aluminium, with aluminium, if the reaction happens, then we can say that aluminium is more reactive than the other metal salt solution. Okay. So let's say, for example, if it is aluminium powder, we'll just record our observations like this. Aluminium powder mixed with, aluminium powder with zinc. Okay. So what is the reaction? If there is a reaction, we put a tick mark. If it is happening, what does it mean? That aluminium was successful in removing zinc from its solution, and what will be formed? Aluminium plus zinc sulfate will give rise to aluminium sulfate, and zinc is displaced out. So when zinc is displaced out, it means that aluminium is more reactive than zinc. If reaction does not happen, it means that the metal which you are taking is lesser reactive than the metal which is present in the salt solution. Okay. So we'll start with aluminium, children. Please do watch this. Let's go to lab and make this and do this experiment where we'll be making aluminium to react with all these salt solutions, and we'll note down in this observation whether it is correct or not. We will check. Okay. Let's see. Let us see the reaction between here is aluminium sulfate, okay, and here we have aluminium powder. Okay, we'll see what will happen if aluminium powder is added to aluminium sulfate. Let us see. I'm adding some water to it. So making a solution of aluminium sulfate. Now to this I'm going to add some aluminium powder. So when I add aluminium powder to the aluminium sulfate, nothing will happen because it's the same. No displacement will happen, and you can see that. So I've just added, and no color change, no reaction took place. Okay. So this is the first reaction where aluminium powder is made to react with aluminium sulfate. Now let us see this same thing with the zinc. Now let us see what will happen when aluminium powder is made to react with zinc sulfate solution. Here is the zinc sulfate solution, and here is the aluminium powder. Let us see. You will see that visibly no reaction will take place, but there will be a coating on the aluminium particles of the zinc actually. So you can see that the aluminium particles can be seen clearly, and there is a coating of zinc. It shows that aluminium is more reactive than zinc. Now let us see what happens to the blue color copper sulfate solution. You can see this is the copper sulfate solution, and here is the aluminium powder, and I'm going to add into this. Let us see what happens. You can see that the blue color of the copper sulfate disappeared, and the displaced copper got deposited on the aluminium here. You can see the blue color disappeared, right? So it shows that aluminium is more reactive than copper because it displaced copper. Now let us see whether iron, is more reactive than aluminium or lesser reactive than aluminium. Here we have iron sulfate solution, and in which I am going to put the metal, aluminium metal. Can you see this is the metal and I am going to put it in this. So observe the color change again, children. What happened to the color? The pale green color of the ferrous sulfate again got changed. Okay, it changed to like grayish color. So that means that a reaction has happened. And when will a reaction happen? Whenever the metal is more reactive than the metal which is present in the solution. So as you can see over here, when because of the color change, we can now know that a reaction has happened, and it is because aluminium is more reactive than iron sulfate. Okay, iron basically. So here is the proof. Okay, thank you. So did you see aluminium could react with zinc sulfate, okay, and it could displace zinc. That displaced zinc could actually formed into a coating. It got deposited over the aluminium particles. You know, that shows that aluminium is more reactive than zinc. The same thing happened with copper sulfate solution also. Here the blue colored copper sulfate got discolorized or decolorized, and which shows that copper is removed from its salt solution. And when will that happen? When aluminium is more reactive than copper. So it gave a positive reaction over here. So this shows that aluminium is more reactive than copper too. And here the aluminium cannot displace its own salt, you know, its own metal. It cannot displace because here also it is aluminium and here also it is aluminium. So such a solution, there will be no reaction. It cannot displace itself from its salt solution. Next is iron sulfate. Now iron sulfate, if you see, it can easily displace iron. We saw that the brown, light green, pale green color of iron sulfate was decolorized again, indicating iron is, you know, removed from its solution. And you can see on the aluminum particles, you will see a dark brown colored coating, which shows that aluminium is more reactive. Can you see in all the three categories you got a positive reaction and observation? So we can say that aluminium is more powerful, more reactive than zinc, than copper, than iron also. So this is on top. The same experiment we will repeat with other metals also. Zinc, we will take zinc and we will see how it reacts with other salt solution. If you take zinc, it will not react with zinc sulfate because it cannot displace itself. You know, the same element over here, metal over here, zinc and zinc. It cannot displace zinc. You can see copper, it could displace. So what does it mean? Zinc is more reactive than copper. Can you see, was there any reaction with aluminium sulfate? No. So it means that zinc is less reactive than aluminium. Then if you see iron, there is a positive reaction. It shows that zinc is more reactive than iron. So if you, in the similar manner, if you see copper, okay, it does not give any positive reaction in any case. You can see all into marks only. It shows that it is least, or what you call lesser reactive than any of these metals, zinc, aluminium or iron. It is lesser reactive than those three metals. Iron, if you take, it is only able to displace copper. That's all. No other element. So you can see only one positive observation. So we can say that iron is more reactive than copper. That's all. But lesser reactive than zinc and aluminium. That's why we got two negative observations and result over here. Okay. So based on the observation, just let us see one more reaction of copper, okay, with zinc sulfate and the copper sulfate solutions, and then we will see how to write, the result. So as you can see that these are the copper turnings, children, and we'll be using it to find out its reactivity. We'll make it react with three salt solutions: zinc sulfate, iron sulfate and copper sulfate, and let us see what is the reaction. So I'm going to add few copper turnings into the zinc sulfate solution over here, and let us see. What could be the reaction here, children? As you know that copper is much below, the metal reactivity series, you will see that absolutely there is no visible change in the reaction. The copper turnings are just like that only, indicating that the copper is much less reactive, and because of which it could not displace zinc. So in the reactivity series, it is much below zinc. That's why it could not displace zinc from its solution, zinc sulfate solution. So absolutely there is no change at all. Okay. Then the same thing if we mix it in copper sulfate solution. Here is the copper sulfate solution. I have taken one copper sulfate solution, small amount of copper sulfate solution, and when I add these copper turnings to it, what will happen? When I add these copper turnings, you will see that no reaction ever happens because both are copper only, right? No reaction, no change at all. There is no change in the color of the copper sulfate solution. So we can say that, we'll tabulate all these observations and we'll find that. So did you see, children, copper did not give any positive result either with zinc or copper, and the same case will be repeated. It will happen both with aluminium sulfate and iron sulfate too. So that's how you can understand now that copper is lesser reactive than zinc, aluminium or iron. Now if you see iron, it will give only reaction with copper sulfate, indicating that iron is more reactive than copper but less reactive than zinc, aluminium. Okay, so that's how, based on all these observations, you can say that this is the report, children. This is the report. We get aluminium to be more reactive because it got more positive reactions and it could displace the other elements from their salt solutions, metals from their salt solutions, and when it displaces, there is a positive observation that we saw. We saw some change in the color, and that indicates that aluminium is more reactive. Then only a displacement reaction is possible, right? So you can see zinc, you can see 2 tick marks you got for zinc. That means it is more reactive than copper as well as iron. So it comes next in the metal reactivity series. After aluminium, we got zinc there. And then iron, it has got only 1 tick mark. That means it is more reactive than copper. That's all. But it is lesser reactive than zinc and aluminium sulfate, aluminium metal. So it occupies the 3rd position. We are just seeing, we are comparing the reactivities of these 4 elements. The least is copper here. Okay, so this is what the report looks like. Now this is the result that we got after our experiments. So which one is most reactive? Here in this case it is aluminium, children. If you carefully see the positions of all those things, aluminium, zinc, iron and copper, can you see the first place is occupied by aluminium, second is zinc, third is iron and the last one is copper. You can see that's the reason why it is arranged in this manner, a vertical arrangement of metals with decreasing chemical reactivity. So that's all about this experiment, and I hope that you understood this concept well. Okay, thank you.